Hello. In this video I'm going to talk about a few of the basic properties of definite integrals. Recall that the definite integral, the integral from a to b of f of x dx, is a number which represents the total change between the values x equals a and x equals b in whatever quantity it is that has its rate of change equal to f of x. So this is the total change, and the x equals a and x equals b there, that x is the same as the x in the d over here, the differential. So this means that if we can find whatever function it is, capital F, with its derivative equal to little f, so little f is the rate of change of capital F, then we could write this number, this definite integral, as the difference in value between antiderivative at b minus antiderivative at a. That's the essence of the fundamental theorem of calculus. Now we described this in our video on the fundamental theorem of calculus by using an analogy with water flowing through a pipe. So we suppose that the integrand, the little f, was the meter reading on a meter attached to a pipe, and water was flowing through the pipe. The antiderivative is a quantity of water accumulating in the bucket at the end of the pipe. And so the integral from a to b is the total amount of water between the times a and b that flows out, given that the flow meter has the readings f of x. And that's our analogy that we're using. We can simplify the notation by leaving out the x equals here and just write the integral from a to b, and then it's understood that whatever variable is after the d at the end of the integral, that is what is equal to a and b here. Okay, and finally there are two properties of definite integrals that I want to mention, and both of these are quite natural rules, and neither of them should be very mysterious. The first says that if we take one interval and we have two different pipes, so we have meter readings from one pipe given by a little f and one set of readings given on the other pipe by g, then the total amount of water is the water flowing out of one pipe plus the water flowing out of the other pipe. So in terms of the mathematical world, if we have the sum of two functions and we take their definite integral, we'll get the same number if we take the integral of the first function over the interval a to b and then add the integral of the second function from a to b. And this allows us to break up functions which are written as sums into simpler integrals. And the second rule says that if you have one pipe but you have two consecutive intervals that you're measuring, the total flow during the first interval plus the next consecutive interval will actually be the total amount over the two intervals combined. So the integral from a to b of f of x dx plus the integral from b to c of f of x dx is the integral from a to c of f of x dx. Now in this case, if you read this rule the other way, it could be telling you that there might be some reason why you want to break up your interval into smaller intervals and then do individual integrals over the smaller intervals. And this rule says that that's just fine.